Hey everybody, Lars here. Tonight, finally, we are going to do a little bit review of what we did with classes from the earlier video, but then we're going to look into two features that come along for the ride when we write our programs using object orientation. One is called inheritance, and the other is called polymorphism. And instead of doing inheritance and doing all of that, and then doing polymorphism and doing all that, we're going to do them both together. And as you see, as we go over the example I'm going to go over with you, it makes more sense to do it that way, and you'll know what I'm talking about as we get going. All right, let's bring up some code. I quick whipped up a class called animal. And just as a quick review, I created a class called animal. It has its constructor. In the constructor, I ask for self, which is the object itself. That's done automatically. And I ask for name of the animal and how much it weighs. So as you can see down here, I set up my two instance variables, the name and the weight, and I set them equal to self.name and self.weight. So that's all we do in the constructor for animal. We just take these two variables and we assign them to their instance variable names. Now I created getters and setters for those two variables. So you have get name, which just returns the name, and then you have set name, which lets you reset it. You can see self.name equals name right here. Because you can't run the constructor again. I mean, the constructors only run when you create the object. So if you want to change one of these variables, you have to actually have a method that does it, and that's what a setter is, a getter and a setter. And I do the same thing with weight. I return the weight, and I let you reset the weight. Maybe our animal will go on a diet, or maybe our animal will eat a banana split and gain weight, whatever. So then I do one last thing at the bottom here. I create a method called speak. Now in this case I just print sound because it's an animal, but we don't know what kind of animal, and we're kind of going to get to that afterwards. So let's, just to take a look really quick, let's use this. I will create a variable called, let's just call it, I don't want to call it animal because we are using that class. I will just call it the animal. I guess not much better. And I'll make it equal to animal. And I will call my animal Fred. And I will say that old Fred weighs 200 pounds. So we've done that. Now, let's see if one of our getters works. I'll say get name. And just print that. And let's see if it works. Uh-oh, already something is broken. Get name is not defined. Of course it's not, because once again I have forgotten to put the variable name of the object in front of it. Now things should work. As you can see, idle will list all of the things that we can do, because idle reads our class and says, hey, these are all the things we can do with that particular object, which is pretty cool because we defined all of that stuff. So anyway, now that I run it, whoop, it runs and it prints out Fred. So let's also do this just to test our variable, or object I mean to say. And let's do it again with get weight. Only this time we're going to use our setter to reset the weight. And I will say the animal dot set weight, and I will change his weight from 200 to 150. Fred went on a diet. And then after I do that, I'm going to print it again to see if my change took hold. Okay. All right. Looks like we're in business. Let's trace through this code so you can see how this class is being used in the main program. I create a variable name called the animal, and I make it equal to the class name and then the two parameters it takes, name and weight. Remember, self is taken care of by Python internally. So technically it's being given the name of the object, which in this case is the animal. So I give it Fred, so name equals Fred, and 200, so weight equals 200. When I come into the constructor, self.name equals Fred, the string Fred, and self.weight equals 200. And that's it. Boom. After that, I have the object, then I can use it. Then I print the animal dot get name. So let's go up here. Is there a method called get name? There is. So I return self.name when it is called. Self.name in this case is Fred. So I print Fred, and that's what happens right there. Okay, so that's why we get that Fred. So then I print the animal.getWeight. Do I have a method that says get weight? Yes, it does. What happens? I return the weight. In this case, when I constructed the object, the weight was 200. So it returns 200 and I print it. Okay. Then down here, I don't print, but I call a method, the animal.setWeight, with a parameter of 150. So do I have a method called setWeight? Indeed I do. It takes weight, which in this case is 150. And this line right here resets the instance variable. So what was set in the constructor as 200 is now being reassigned what I passed into setWeight, which is 150. So now the instance variable, self.weight, is equal to 150. And then I come down here and I print it, and I get 150. So hopefully you're seeing a couple of examples now. You're getting the idea how classes work, how we use them, what they can do, things along those lines. So that's just a little basic review of a classic class in action. But now, let's say I want to do something different. Let's say I want to create a class, but I want to call it cat, and I want to define a cat that I'm going to use in my program. Maybe I'm doing a video game. Maybe I'm in a vet's office and I want to keep track of all these animals for a database or something along those lines. So I have the animal class already sitting there, and it's got a constructor that takes name and weight as instance variables. It's got getters and setters for those two variables. It's even got a speak method. I don't want to type all that over again when I create my cat class. So is there a way that I could use that, what's already written, and just take it and get a copy of it maybe, or use it? There is a way to do that, and that's what's called inheritance. I can create a new class, but when I create that class, I can inherit that class that I want to use. And the way I do that is I define the class by saying class, and then I'm going to call it cat, but then in parentheses afterwards, I'm going to write animal and tell it what class above it, defined above it, or already declared in a library that you import, that I want to inherit from. So I do that. What's the next thing I do? The next thing I want to do is I want to define the constructor for cat. And there's a little trick that we do in here. So I'm going to say def. I'm going to do my dunder. I'm going to do a init for initialize. I'm going to call it init. And I'm going to say self, which we always do. Just like animal, I'm going to ask for name, and I'm going to ask for weight. And something different for my cat, I'm going to also take a color. Okay? So I do that. Now, classically, like we did up here, I now want to set my instance variables, but we're doing something different here. We're using animal. So when we use or inherit from a class, it's almost like it's the parent class. You would call this a parent class up here, animal, and this would be the child class. Other way of saying it that you'll see a lot in computer programming is a superclass versus a subclass. So the first thing we do when we inherit from a class is we want to set up that object just the way we would have set it up previously. So what do I want to do? I want to take name and weight, and I want to call animal's constructor. But how do I do that? I mean, init is being used here in my cat class, and I can't just call init up here, so how would I do that? This is the way you do it. You type the name of the class, and then you say dot dunder init dunder, and you call it with self, name, and weight. You do not include color. Color is something that we added on to cat. Animal has no idea what color is. It only takes name and weight. So that's all we're going to give it. Okay? Then, because we have color in our cat class, we're going to add it. We're going to say self.color equals color. Color is just going to be a string. And that's it. That's our constructor for our cat class. Okay? Now, and I'm going to show you, I'm going to talk about it a little more in a bit because this is more of an example of polymorphism than inheritance. We have getters and setters for name and weight, which is fine because that's what we want, but we don't have a getter and setter for color. So basically what I want to do is I want to create two new methods. One called getColor, and real hard, all we do is return color, done. And another one called setColor. How the cat's going to change color, I don't know, so this isn't really one that you'd do a setter for, but I'm going to do it anyway. Because it's a setter, it takes a variable, and all we do is reset the variable, just like we did in the constructor. So that's done. You see how easy that is? Boom, boom. We got getter and setter for our new variable that we use in our cat class called color. Now, one last thing we're going to do, what I was speaking about before, when it has more to do with polymorphism than anything else, is I am going to change that speak method. Instead of just printing sound, because it's a generic animal and I don't know what it's going to sound like, I'm going to print meow, because I know now I have a cat. Okay? So, this is the trick, and you're going to see this when we use this class. Cat, when I create a cat object, can do everything animal can do. I can call get name on it, I can call set name on it, I can call set weight, I can use all of those things, but now I also can do color, and when I do speak, it will not print sound because I have overridden that method or given it a new one to use instead, and that one prints meow, and I think you'll understand that a little better when we do an example, because I'm going to trace through the code when we do an example. We have finally gotten to the point where we're going to run out of real estate because we've got so much code that our code is getting long. Let's see if I can do this right. Okay, I'm going to say the animal, and I'm going to make it equal to animal, and I'm going to call him Fred, and he's going to weigh 200 pounds. Boom. Then I'm going to do another one. I'm going to call it the cat. Only this object is going to be a cat object, and I'm going to name him Felix. And Felix is only going to be 12 pounds. That's actually a pretty fat cat, but I guess Fred is a gorilla or something like that. A little bit bigger. Fred maybe is a human. So I have done that. So now, oh, actually, I made a mistake. I don't want any bad luck, so he will not be a black cat. We will make Felix a brown cat. Okay? Because in our cat object, we have color. You don't have that in animal, so you don't include it. So we can do that. Now, let's do a get name for Fred. Copy, and let's do one for Felix. Let's see what we get. Okay, we printed their names. As you can see, I have an animal object. I said get name, and it printed the name. I have a cat object that I created, and I said get name, and I printed the name. Now here's the trick. We're going to trace through the code. I said the animal equals class animal with Fred and 200. So I went up to animal. I ran the constructor. Name was set to self.name. Weight, which is 200, was set to self.weight. Done. That line is over. Then I went to the cat equals cat Felix 12 and brown. So what did it do? It went here to class cat because that's what I asked for. So it went up to class cat. And when it looks at class cat, it sees the animal there. So we'll get to that in a sec. So what did I do? I have name equal to Felix, weight equal to 12, color equal to brown. I call the animal constructor with name and weight, Felix and 12. So I come up here. Self, which is the name of the variable, which in our case is the cat. Name, which is Felix, weight, which is 12. So self.name is equal to Felix. Weight is equal to 12. Even though I'm using the animal class, it's still the cat object that's calling it and using those variables. Then, because I use the cat class, the color, which is brown, is right here. I just set equal to an instance variable in my cat class called self.color. All right, stick with me. This gets clearer in 2 seconds. So that's what happens when I create these two objects. Now, I print the animal.getName. So that object, the animal, what kind of class is it? Animal. So I come up to animal. Is there a method called getName? Dum dum. Yes, there is. What do I return? Self.name. Self.name, the instance variable for the animal, is Fred. So I return Fred. So when I run that function, it returns Fred. Boom. And that's what we get over here. Now, and this is the interesting part, the cat.getName. I have the variable the cat. What is the cat? It comes from the cat class. I go up here to cat. GetName. I look through my methods. Is there a method called getName? No. So when Python sees there's no method called getName, it comes back up to the class declaration and says, am I inheriting from somebody? And yes, you are. You're inheriting from animal. So Python will say, oh, okay, let me go to animal. You come up to animal and you do it again. You look down the list and you say, hey, is there a method called getName? Now there is. So what do? You return self.name. So that's exactly what gets done. For the cat variable object, name is Felix. So you return Felix. Okay? Now, if I say print the animal dot speak, well, I don't have to print it because it actually prints it in the thing. I just have to say the animal dot speak to have the animal speak, and I have to say the cat dot speak to have the cat speak. So let's see what we get. Okay, I print the names. Let me get rid of that to make it clearer. All right, sound and meow. So what happened here? The animal.speak. The animal is what kind of class? Class animal. I go to animal. Is there a speak method? There certainly is. It says print sound. So that's what happens. Now, the cat.speak. The cat is what? A cat class. So I come up to cat. Is there a method called speak? Yes, there is. Only this one prints meow. So that's what I do in this instance. The type of class the object was created with is the first place you look for methods when you call them. If the method is there, you run it. If the method is not there, then you come up and look for it in your inherited class. So this is an instance of what we call polymorphism. And if you think about what the word polymorphism actually means, it means poly, many, or morphism, which means forms or change. We use it as it means forms. So many forms. So even though when you look at this code, that's the same function call speak, and that's the same call speak, but they do different things because they're different kinds of objects. And we've defined them differently in our different classes. Now, we're going to get more into this in the third video when I discuss overriding functions, and there's also something we can do with functions called overloading functions, but we'll discuss that in the next video. Python doesn't really support overloading in its classic form, but overloading is another form of polymorphism. It's where you can have methods actually with the same name defined in the same class, and the only thing that's different is their parameter list. And the name of your method and the parameters it takes all put together is what we call a signature. And all methods have a signature. The method signature for set color is self and color. And if we were doing overloading, it would be set color and then perhaps more parameters. But I don't want to confuse you. Forget about that for now. We're going to discuss overriding versus overloading when we do the third review video. I'll probably do that over the weekend. But just for now, just to keep it simple, polymorphism, as it's being utilized here, is just the fact that I have a speak method in animal and I have a speak method in cat. And even though I'm inheriting from animal, when I create the cat class, I have overridden the speak method so that when I run it with my cat object, it says meow. Okay? So just one more time, I'm going to print the cat.getWeight. And that prints 12. Now, why did it print 12? Print the cat. The cat is what? It was created with the cat class. So it's the type of object is a cat object. Get weight. I go to the cat class. Is there a method called get weight? There is not. So I come back up to the declaration and I say, did we inherit from anything? We have. We inherited from animal. So now I go up to animal and I say, is there a method called get weight? There is. I find it in animal. It says return self.weight. Weight, when we created cat, was defined as 12. So I return 12, and that's what I print, and that's what we have printed right there. Okay? I'm going to take this code. I called it U5, Unit 5, R2, Review2.py, and I'm going to put it in our resource folder for Unit 5. Take a look at this. Play around with it. Look at what I did. I am going to, when I do review video 3, I'm going to bring this code back up. We're going to review it again, and then I'm going to add some new features to it. And if you've read the slide, you know what kind of features I'm doing. We're going to look at one feature called a class variable, where I can create multiple objects with a class, but those objects will all share a particular variable. We call that a class variable, versus an instance variable, which is only for that particular instance. When I create this variable, the cat, and I create cat, Felix, 12, and Brown, those variables are just for that one object. Okay, those are instance variables. When we create class variables, there will be an overriding higher level of variable that every object of that type will be able to share. And that actually comes in handy, definitely in video game programming and some other things. We are also going to discuss the opposite of the constructor, which is called the deconstructor. And as you see here, we've created objects. There is also a way to destroy objects or get rid of them or get them out of memory. Back in the dinosaur days, when I learned how to program, memory as well as compile time, but memory was very scarce. So when you learned how to program, you had to learn different ways to save memory. So when you weren't using something anymore, you made sure to get rid of it and return that memory to your program so you could use it for something else. A lot of times when people program nowadays, they won't bother with deconstructors because we are lousy with memory. It's very cheap now. There's huge amounts of it, RAM and hard disk space. So a lot of the things we used to do when we learned programming, we don't really have to do anymore because there's tons of memory to use. And it sounds bad to say it this way because it sounds wasteful, but I mean, there's so much memory that we really don't care. Memory management isn't as important. There's always a ton more. That said, we still need to learn these techniques because it's a good thing to know in case you do run into a situation where memory is limited, or you definitely want to be elegant and concise with your code and make it run faster. The last thing we're going to review is overriding functions versus overloading functions. And again, it's a tale of two cities in Python because technically Python doesn't support overloading in its true sense. But there are ways around that. And we're going to find a way to create one single method but make it so that it can take a varying amount of parameters for our things, okay? So hopefully this wasn't a bad one. I don't think it was bad lengthwise. Take a look at the code. Remember, it's YouTube. You can stop it. u5r2.py in your resource folder, and you can look at it and understand what we're talking about when we talk about inheritance and we talk about polymorphism as far as object-oriented programming is concerned. All right? Okay. Announcements. Grades. Eric is, as most senior undergraduate students are, he is swamped, but he is going to finish all of the grading for the assignments. Tomorrow morning, I'm going to go into the cave and do it with him. So hopefully tomorrow and maybe a little bit on Saturday, I'm going to send out all your grades for Unit 4. So you will have that. Don't worry. It is on the way. No worries. Second thing, the assignments are out there. The assignment is to create a class that models a deck of cards. Don't freak out. It's not that bad. If you think about it and you read all your resources and you use the web, you should be able to think of a decent way to model a deck of cards. And then the second program is just to use that deck of cards to play a game with it. And that should be easy for you. That's a bunch of take input from the user and if then else and boom, boom, boom. So you shouldn't have any problems as far as that's concerned. So we have that. Third thing, I got a couple emails from a couple different project groups today concerning the final project. And everybody's asking these complicated questions like, I'm using this HTML parser to scrape the web, and I'm using this library to do this, and I'm doing this to do that. And I've been telling people, look, concentrate on the Python. Concentrate on meeting the requirements of the rubric that we gave you. If you hand me and Eric a program on the 16th of December and it requires 5 different libraries that we can't load, we're not going to be able to test that program, and we're not going to be able to run it. So at that point, I don't know what we're going to be able to do for you. So try to keep it simple. As I said to somebody today, I think it was Garav, I said, look, in this day and age, I think you can assume your average Python programmer has NumPy, has Matplotlib, and has SciPy. But after that, you can't really make any assumptions. So if you have a piece of code that uses some weird esoteric third-party library to look for HTML tags in a web page, and I can't load it via pip, or I can't find a way to load it, there's no way I can run your program. So try to keep the program simple. Don't mind you using a third-party library, but it's got to be something that's going to load. Especially on my system, I can tell you right now, I'm using 64-bit Python, and I'm running version 3.4. I haven't upgraded to 3.5 yet, so I'm 3.4. So that's what I'm running on my system, and that's where we're going to be looking at the programs and doing the assessment when the final programs come in. So just keep that in mind. And as I told a bunch of people today too, don't think you have to reinvent the wheel. I thought all the projects were fantastic. Some of them were really clever, really interesting. But don't think you have to come up with a piece of code that fully realizes all those ideas. Meet the requirements of the rubric and do a component of that bigger project. It's got to be a decent piece of code, and you've got to have the right size data file. You have to do file input and output. You have to have your own library. We're going to be looking for all of these things, but I don't want you to have fully implement with a web front end and all of these different things that I'm hearing. You don't have to go that crazy, okay? We want to see you take a project of your own making and use the skills you've learned in the last 10 weeks. And that's really all we're looking for on that, okay? Timing-wise, you have this weekend coming up, then there's Thanksgiving, and then you have the weekend after Thanksgiving, and the unit, I have all the assignments due on December 2nd. I believe we're going to do the quiz on December 1st, and then real quick, December 3rd, we're going to start Unit 6, which is data structures. I'm going to tell you right now, Unit 6 is not going to be a backbreaker. I'm going to discuss a lot of data structures, stacks and queues and binary trees, but I'm also going to discuss linked lists, and the program you'll have to do for Unit 6 will have to do with linked lists, but I'm not going to break your back on that because I know you're going to be spending a lot of time and doing a lot of work on your final project. So don't get scared and think you're going to get overloaded those last 2 weeks of December. Unit 6 is going to be distinctly lighter than most of the units you've been seeing down this road. All right, so I don't want you to get, and no trepidation about that. Plan ahead, put aside that time to get your programming work done. But Unit 6 is not going to ruin your Christmas shopping, let's put it that way. It's going to be some stuff to know about, and you're going to get a quiz and programming assignments, just like you've always gotten for these units. But it's not going to be as much work as perhaps some of these other units have been. So I don't want you to be scared about that. I'm going to leave you ample time to work on your final projects. Okay? I think that's it. I can't think of anything more. So this is the second video. Over the weekend, I'll put together that third video where we do some finishing things, and we'll go over a final setup, probably this animal, cat, maybe I'll add a dog class, and we'll do class variables, and we'll do some things with deconstructors, and we'll have it all in one file that you can use to play around with and see how these things work, okay? Good. Then you have a good night. Take this slow. Read all the materials. It'll come to you. It's not that bad. And actually, it's a good way to organize things in your mind after you've gotten used to it and you use it for a while. It makes sense when it comes to programming. All right? Then you have a good night, and I am getting out of here. Talk to you later.